Hello everyone, welcome to the pre-algebra lecture. In this lecture, we're going to start a new module, Module 4, where we discuss the basics of algebra. Okay, so this will get you a little bit prepared for your next course, which will be in Algebra 1. So this first section is an introduction to basic algebra. Basically, a lot of it is going to be translating from an English phrase to an algebraic expression and vice versa, going the other way as well. So let me start by giving a couple of definitions. So the first definition I want to give is the idea of a variable. So a variable, you can think of it as a letter. Typically we use X, but really you can use any letter you want. And that letter represents an unknown number. So I'll say it's a letter that represents an unknown number. Right? And often, or eventually, we're going to be solving algebraic equations for variables. We're going to figure out what the unknown number actually is. Okay, so that's a variable. A constant is simply a known number. So in our case, it could be a whole number, it could be a decimal number, it could be a fraction, right? So a constant is just a known number. And an algebraic expression in general, so algebraic expression, let me write this a little better. Is an expression that combines variables, constants, and operations, right? Arithmetic operations, addition, subtraction, multiplication, division, and so on, raising to a power as well. So it's an expression that combines variables, constants, and arithmetic operations. Okay, so an example, let me give you a couple of examples of algebraic expressions. So some examples would be things like x plus 5, right? That would be an algebraic expression. Or maybe 2x minus 4. That would be an algebraic expression. I don't have to use x as my variable, right? So I could say maybe 3/8 times t, right? That would be an algebraic expression. Or 5y plus 6. So in the last two examples, t was my variable and y was my variable. Okay, so those are algebraic expressions. Now, one of the most important things we want to be able to do is to translate a phrase into an algebraic expression. So let's look at some examples of that. And you're going to notice that there's like key words that end up representing some particular operation. Okay, so for example, let's say we're asked to translate each phrase into an algebraic expression. So if I give you a phrase like, maybe, here, I'll start with an easy one. Let's say d, that's my variable, right, plus 12. Okay, so that translates directly, right? We know the plus means addition. So you would write the algebraic expression as d plus 12. How about this? What if I write the sum of x and 11? So then you have to recognize the sum, right, is basically the result of adding two numbers together. So the sum of x plus 11 would be x plus 11. That would be the algebraic expression. What if I write the difference between a number and 8.2? Okay, so difference, right, is the result of a subtraction. So I want the difference between a number. We can call this whatever we want. So we're free to choose our variable name here, right, a number. Again, people typically use x, but you don't have to. So if translating this into an algebraic expression, it would be, let's say we're going to use x for our number, so it's x, and then it would be minus 8.2, right? That would represent the difference between the number x and 8.2. The product of 5, and let's call our variable p. How would I write that? Well, that would simply be 5 times p, right? So this would be 5 times p. Now, if you write a constant right next to a variable, you don't need to put the multiplication symbol. It's implied. So if I just write 5p, that also represents 5 times p. Okay. Oh, how about this? This one you have to be a little careful. What if I say 9 less than y? So 9 less than y. So for instance, if y were like 12, right, 9 less than 12 would be 3. If y were 20, 9 less than 20 would be 11. So how do I write this? It's actually going to be y minus 9, right? I'm subtracting 9 from y. That's what 9 less than y means. That's how you'd interpret it. So it'd be y minus 9. So you have to be careful. It's not 9 minus y, it's y minus 9. How about x increased by 2/3? So increase, right, is another way of describing addition, right? So this would simply be x plus 2/3. I start at x and I want an additional 2/3, so I'm adding 2/3 to my x. Here's an important one we're going to see a lot in word problems. If I write 2/3 of y, the of really means multiplication. This of means multiplication. So this you could write as 2/3. And remember, I could just put the y next to it, and that implies multiplication. So it'd be 2/3 y. Now, of course, we could also go the other way, right? I could give you an algebraic expression and ask you to come up with a word phrase that describes it. So let's try a couple of those. Let's say we want to translate to a word phrase. So I'll start with, let's say, 8 plus r. There's many different answers for this, right? You could literally say, well, one way of translating this is this means 8 plus r. Or another way is maybe r more than 8. Right? That would also mean 8 plus r. Or the sum of 8 and r, etc. Right? So if you go this way, if you start with an algebraic expression, you want to write a word phrase. Typically, there's many ways you can actually write that word phrase. So I'll just say there's many answers. I kind of mentioned the most common ones though, but there's many answers for doing this type of thing. Let me do one more. Let's say I give you, here's the expression. Okay, so 4 fifths y, and I want to write that as a word phrase. Well, one way is simply, remember this means 4 fifths times y. So that's one possibility. Remember, multiplication is of, so I could say 4 fifths of y. That means 4 fifths y. Or since I'm multiplying, I could say this is the product of 4 fifths and y, right? Multiplying those two together. So I'm finding the product. Okay, so that's going from algebraic expression back to a word phrase. Now, mostly we're going to do the other direction, right? We're going to start with some word phrase and end up with an algebraic expression. All right, the other thing I want to talk about in this section is evaluating algebraic expressions. So how do we evaluate algebraic expressions? So the first step is you simply substitute the given value in for each variable. And then carry out the computation. You have to be careful, right? You have to make sure to remember your order of operations. So I'll say carry out the computation. And I'll just remind you, remember the order of operations. Okay, so let's do a couple of examples here. Let's say I want to evaluate three plus n if n takes on some particular value. Let's say n is 2.9. So I'm simply going to add these together, right? So I want to add 3 plus 2.9. Well, we reviewed how to add decimal values together. I can write the 3 as 3.0, right, plus 2.9. I line up the decimal points here. So 0 plus 9 is 9. 3 plus 2 is 5. This is going to equal 5.9. Right, so all I did was substitute in that value, right? And then I do the computation. I simplify it. Here's another example. Let's say I have 7 minus x. So I want to evaluate that expression if x takes on the value of 4.5. So this is really going to be 7 minus 4.5. So really here I'm just subtracting decimal values, right? So you could write this as 7.0 minus 4.5. Line up your decimal points. I need to borrow. So 10 minus 5 is 5, and then 6 minus 4 is 2. So this is simply equal to 2.5. How about 4 fifths n if n is equal to 30? All right, so I go to my expression, right, where I have an n. I'm going to plug in 30. I can write it as, since I already have a fraction there, 4/5, I can write 30 as 30 over 1. Now I need to multiply them, right? Because remember, 4/5 n means 4/5 times n. But before we multiply, you probably want to simplify. It looks like we can simplify, right? 5 goes into 5 once. 5 goes into 30 6 times. So now if I multiply numerators, I have 4 times 6 is 24. Denominators, 1 times 1 is 1. And that's just equal to 24. So it would just be 24. And how about this one? 1/3 y. I want to evaluate that if y is equal to a half. So again, I go to my expression where I have a y. I'm going to plug in a half. And then I carry out the computation, so I have to multiply those fractions together. I can't really simplify first, so I'm just going to multiply numerators. 1 times 1 is 1. And denominators, 3 times 2 is 6. And that would be my answer. So it's equal to 1/6. Okay, now to finish up the section, let's just do a couple of questions from my open math. So this question says, Mr. Smith and Mr. Stein were driving to a business meeting 250 miles from their office. Mr. Smith drove the first X miles, then Mr. Stein drove the rest of the way. Write an algebraic expression for how many miles Mr. Stein drove. So it might help to draw a picture, right? If, let's say this is their office, right here. Let's say this is their destination over here. So this distance, that's going to be 250 miles. Right? So this is 250 miles. Then they tell us Mr. Smith drove the first X miles. We don't know what that is, but let's just say this distance is X. Okay, so that's Mr. Smith. And then Mr. Stein drove the rest of the way. So Mr. Stein drove from here to their destination. So how do I represent that in terms of the information I already have? Well, this is really going to be the difference, right? It's what's left over. If the total distance here is 250, and this first distance that Mr. Smith drove is X, then Mr. Stein must have driven 250 minus X, right? That's the remaining distance. So this must be 250 minus X. And that's going to be the correct algebraic expression, 250 minus X. Okay, it's the remaining distance that's left over. Okay, how about this question? We're told Manuel's age is 4 years less than twice Nico's age. If you let T represent Nico's age, write an expression for Manuel's age. Okay, so, or maybe it's Nico, I'm not sure if I'm pronouncing his name correct. Let's say Nico's age is T, right? We don't know what it is, but we know it's equal to T. We're representing as T. That's our variable. So now we're asked to find Manuel's age, right? Write an algebraic expression for Manuel's age. And we're told Manuel's age is 4 years less than twice Nico's age. So I first have to do twice Nico or Nico's age. Well, that's going to be 2 times T, right? So if Nico's age is 10, twice that would be 20. 2 times 10. If Nico's age is 8, 2 times 8 would be 16, right? That would be twice it. So it's 2T. And Manuel's age is 4 years less than twice Nico's age. So what do I need to do? I need to subtract a 4 here. Okay, so the expression should be 2T minus 4. We can check this, right? Let's say Nico's age is 8. So then Manuel's age should be 4 years less than twice. So twice 8 would be 16, and then 4 years less than 16 would be 12, right? So Manuel's age should be 12. Let's see if it makes sense. If I plug in now 8 for T, then this is going to be 16, I have to do multiplication first, minus 4, that equals 12. So that checks, so it makes sense. So that must be the correct expression, 2t minus 4. Okay, and the last problem here, we're just asked to evaluate this expression, so 8z minus 12, when z is 7. So again, how do we do this? I go to my expression, and where I have a z, I'm going to plug in, substitute in 7. But I have to use order of operations, right? So multiplication has to be done before subtraction. So I multiply 8 times 7. What's that? 56. And then I can subtract 12. And then 56 minus 12, if you work this out, right, this is going to be 4 and then 4. So this is going to be 44. So the answer is going to be 44 if we evaluate it when z is 7. All right. So that's it for this intro section. Next section, we will talk about solving addition and subtraction equations. Thanks.